Hello again. Alright, we're going to do a couple of AND problems this time. So take a moment, again, pause the video, then we will do this problem once you've copied it down. So in this problem, we've got that situation where the AND problem is written as a single inequality. Okay, negative 7 is less than or equal to 5x plus 3, and 5x plus 3 is less than 33. Okay, we solve this all at once. Okay, we'll start by subtracting 3 from everywhere. And this is the key. When it's written like this, we have to subtract from everywhere. So I get negative 10 is less than or equal to 5x, which is less than 30. Okay, notice I keep those signs. I bring that sign down and I bring that sign down. It stays in the same format. I'll divide by 5 everywhere now. And I get negative 2 is less than or equal to x, which is less than 6. Alright, so what I've done, again, my goal is to isolate x in the middle. Alright, I've done that. I subtracted 3, and then I divided by 5. So now x is in the middle. This says x is bigger than or equal to negative 2, and x is less than 6. Right? Now when we're drawing a number line for this, what we do is put our negative 2, or put our critical values, negative 2 and 6. Right? It is an AND problem, so whatever number we pick has to make both statements true, which really means it has to make this entire statement true. So x better be bigger than negative 2 and smaller than 6. Well, think about your number line. Where are the numbers that are bigger than 2? Okay, bigger than 2, those are to the right. And smaller than 6, they're to the left of 6. Okay, so if I test out numbers, I'm going to get a false here. I'm going to get false here because negative 10 doesn't fit in between there. Positive 10 doesn't fit in between negative 2 and 6. Okay? Now negative 2 itself, I can fill that in. Okay? Because its x is greater than or equal to negative 2. So I get a filled in circle there. Oops, that's not what I want. Let's do it with a pen. Okay, filled in circle at negative 2. At 6, though, it's open circle because this says x is less than 6. And in between, that's going to give me a true statement. Okay, because any number I pick that's in between those two will make this inequality true. So I will shade in the middle. And there's my graph of this AND problem. Okay, so I've got the solution here. I've got the graph, and now I'll write my interval notation. Label negative infinity and infinity, but I don't need them because my shading begins to the left at negative 2, and it shades all the way up until 6. So that's my interval notation. Alright, let's try one more here. Pause the video and copy these down. Alright, and then don't forget this is an AND problem. That symbol there means AND. Okay. Let's take a look here. I gotta solve both of these. Alright, now this is one on the left here where it's a common mistake is to multiply by 2 first. We have to subtract 1 to get this x term alone before we multiply by 2. Okay, so I'm going to subtract 1 from both sides, and I get 3 is less than or equal to x over 2. And now I can multiply both sides by 2. And when I do that, I get 6 is less than or equal to x. Okay, and now let's solve this side. Here, all I've got is a fraction multiplied by x. It's negative. Alright, so what I can do is I can multiply by the reciprocal on both sides. So let's do that. I'm going to do negative, and when you when there's a negative here, we got to multiply by the negative. So the reciprocal is negative 2/3 times the negative 3/2 that's there originally. Let me do that in the white color again. Negative 3/2 x, which is less than or equal to negative 3, and I have to multiply that by the same reciprocal times negative 2/3. Okay, I'll put that negative 3 over 1. On my left side, the 2's cancel, the 3's cancel, the negatives cancel, and I'm just left with x is less than or equal to, oh, hold on, I multiplied by negative 2/3, so I have to flip my sign. So x is greater than or equal to. On the right side, let's see what cancels. The 3's cancel and the negatives cancel, so I'm just left with 2. That doesn't look like a 2. Try that again. 2. X is greater than or equal to 2. So there's my inequality solution. It says that 6 is less than or equal to x, and x is greater than or equal to 2. Okay. So we go ahead, we draw our number line. We're going to test out, let's see, my numbers are 2 and 6. And let's see, what can we do here? We got to test our sections. All right, so on the right, let's test out 0. Okay, remember, it's an and, so I need to make both statements true. Is 0 bigger than or equal to 6? Nope. So I know that this section here is false. And actually, let's think about that. I need a number that's bigger than or equal to 6. So 2 is not going to work. That's going to be false. Open circle there. Anything in between here, anything in between 2 and 6, is also not bigger than or equal to 6. So that section's false. 6. Okay, well, let's see. Is 6 bigger than or equal to 6? Yes. Is 6 bigger than or equal to 2? Yes. So I'm 2 for 2 there. So 6 is my first number that's finally true. Okay, remember, all these first beginning 3 were false because I need to make both statements true in an AND problem. Okay, and finally, let's try a number over here like 7. 7 is bigger than or equal to 6, and 7 is bigger than or equal to 2. So we're good there. That section is true. So I'll shade there, and that's my final solution. Okay, this open circle at 2, it might as well not even exist, right? We don't have to worry about that for our interval notation. It's not shaded. Your interval notation only describes what we shaded. So let's do that again. Here's my interval notation. And my shading begins at 6 with a bracket, and it continues on all the way to infinity. Oops, I should label infinity and negative infinity on my number line. Okay, hope those were helpful. Thanks for watching.